Hi everyone, welcome back to Geeks for Geeks practice. So quickly give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine, so that we can start off with the problem for today as well. Hi Rishit, hi Vanshika. So all of you can quickly give me a +1 in the chat and hit the like button as well, guys, so that we can get started with the video. I'll just quickly check the audience. Okay. So I think a little less people are there tonight. Okay, so everyone can give me a +1. Hi, Yuvraj. So let's get started. I think the audience is pretty less today. So let's get started with the problem now. So I'll quickly share my screen as well. And you can let me know if my screen is visible. Hmm. Okay, so I've shared my screen as well. I hope that it's visible. Is it visible? Hi, Harshal. So all of you can hit the like button, guys, if you haven't. And then I can proceed with this question as well. All right. So seems fine. Now, what does the question say? The question says that you have to find the shortest path. Okay, the first thing is that you have to find the shortest path. This is a graph. Okay, like you are given a matrix. The first thing is that you are given what? You are given a matrix. Okay, 2D matrix to be honest. And in this you have to find what? You have to find the shortest path. Okay, you have to find the shortest path. Now, when I talk about finding the shortest path, which algorithm comes to your mind? Breadth first search. Please write BFS in the chat. When I talk about undirected graph, like when I talk about a normal graph or a matrix which is not weighted, then the concept that comes to your mind is nothing but breadth first search. Correct? Yeah, BFS. Correct. Everyone can write BFS in the chat. Okay. So the first thing is that in this question, we'll be using BFS by removing at most k walls. Okay. So basically, suppose that if I give you a grid like this, let's say if I give you a grid like this, let's say it is 0, 1, 1. Okay. 0. Let's say 0. Let's say 1. Let's say 0, 0, 0. Okay. So if you start from this cell and let's say you want to reach this last cell, okay, and you are given k is equal to 3, suppose. So what you can do is like basically 0 will indicate that you can pass through that cell. Okay, there is no blockage, but 1 will indicate, 1 basically the number 1 will indicate that there is a blockage, there is a wall. So at the most 3 walls you can, like if there are 3 walls in your path at the most, then you can, like if there are 3 or less than 3 walls, then you can pass through them. So basically what will happen, you can see that I'll be able to pass through this route. Correct? Because I can encounter 3 walls. Correct? So if you will see, I have to do what? I have to find the shortest path. So I have to use BFS. Okay, and I have to find the shortest path, length of the shortest path, such that I start from this cell and I reach the ending cell, and I can only pass through at most k walls. Okay, is this point clear? At most k walls. Is this point clear to everyone? Please write clear in the chat, guys. Is everyone clear with the problem statement now? Is everyone clear with the problem statement? Quickly let me know. Is everyone clear with the problem statement, guys? Okay, great. Let's move forward now. So what does the question say further? So as you can see, it says that 0 will represent empty cell, 1 will represent a cell with a wall which you cannot walk through. Okay, now you are given integer k. Okay, that is also fine. You can do what? You can move in 4 directions. Okay, so from a particular cell, like if you are at a particular cell, let's say in the grid, if you are at the cell x comma y, so what you can do is you can move up. So moving up means what? Moving up. So one row up. So that will mean x minus 1, and in the same column, so y. Okay, this is another coordinate. If you move up, if you move to the right, then the row remains the same. So x will remain the same, and y will increase by 1. So y plus 1. Or you can move down. So that means you can move to x plus 1, right? X plus 1 comma y. If you move to the left, so if you move to the left, so that means the row remains the same. So x will remain the same. Column will be nothing but y minus 1. Okay, is this point clear? We can go in 4 directions. You can go up, down, left, right. Is this point also clear to everyone? Quickly let me know, guys, and then we'll proceed further as well. And you can hit the like button if you are clear till this point. Okay, so I think everyone is clear. Now it says that what you are given is you are like you can remove at most k walls, and you have to return the minimum steps that you need to start from the topmost corner, that is from 0 0, and you want to reach the bottommost cell, that is n minus 1 m minus 1. Okay, if there is no path, if there is no path such that you can reach from the topmost leftmost cell of the grid to the bottommost rightmost cell, if there is no path such that you can reach from here till here, then you will have to print a -1. So you can write -1 in the chat as well if you are clear with this point, and then we'll proceed further with the question. Okay, so if you will see this particular diagram here, like I'll quickly draw it up so that things are more clear to all of us. So let's say if we have 0, okay, we have another 0, and in this path we have 0 0 0, then you have 0 0 1, okay, then you have 0 0 1, then you have 0 1 0. Okay, if you have this particular path, now what you need to do is you want to reach from here till here, and you can see that k value is given as 1 by passing, like by passing through at most one wall. You can pass through only one wall. So you can see here what I can do is maybe I can go here, right, one step, then in the second step I can go here, right, in the third step I can go here, right. So basically you can see that in this particular question the answer is 4, right, because in 4 steps you can see that I can reach there. If you will see clearly here, so what will happen, see, one step, second, third and fourth. So you can write 4 in the chat. In 4 steps I am able to reach, because this was a wall obviously, but I can pass through one wall because I can pass through at least one wall. Is this point clear? Like I can pass through one wall. So I was given k value is 1, so I'm using it on this wall 1, and there are 4 steps, 1 step, 2 step, 3 step, 4 step. So all of you can write 4 in the chat. Okay, going further, let's go further as well. So let's see this particular example. So let's say if you have been given this particular example, that is nothing but 0 1 1 0. Okay, so if you want to reach from this cell to this cell, and the key value is given as 0, so that means in your path you cannot pass through any wall. So that means the answer will be -1 for this case. Please write -1 in the chat, guys, and hit the like button if you haven't already. This point is also clear to everyone? Till this point everyone is clear, and then I'll proceed further as well. You can write -1 again, because for this the answer won't be possible. Now what you need to do is you'll be given a grid of n cross m size, and you need to return your answer. So first things first, can I say that the first thing that we require is a visited array, correct? A 2D visited array of n cross m size. Okay, and initially I will mark that particular visited array as -1. Every state will be marked initially as -1, because initially I must have not visited any cell, so I'll mark all of them as -1. Okay, please write VIS in the chat if you are clear with this point, that I'll require a visited array, correct? So for that, what I'll be doing here is, let's say that we have this thing here. So what I'll do is I'll declare a visited array, vector of vector int, okay, and I'll name it as visited, and then what I'll do is, let's say n comma vector int m comma -1. So basically I'll initialize every state as -1. Okay, we are why are there so many graph questions in POTD these days? Shubham Ja, I cannot decide what has to be covered in POTD. That totally depends on the team. Okay, now there's another thing, guys, understand this thing. When I am at a particular cell, like I'll be applying BFS, so I will be using a queue data structure, right? I'll be using the queue data structure. Now, in my queue data structure, the first thing is that, can I say that I want to store what? I want to store the x-axis of the current cell that I'm at. I want to store the y-axis of the current cell that I'm at. Please write XY in the chat. I want to store the x-axis. I want to store the y-axis. Is this point clear? I want to store the x-axis and the y-axis in the queue, first of all. Correct? In the queue, I'll want to store x-axis, y-axis. Another thing that I will like to store is what? Like you can say, another thing that I would like to store is what? Let's say if I was at this cell, okay. So at this cell I had four, like at this cell I had k number of, like let's say k is equal to 4. Okay, so in this cell initially I can go through 4 walls. If I'll go, like let's say if I go to this cell and this is having a 1, okay, if this cell is having the value as 1, so if it is blocked, if I'll go through it, can I say that the k value will get updated for this cell, right? The k value will be 3 for this cell. Let's say if I go down to this cell, okay, and I go to this cell. So this, for this cell, the k value will be 4. Correct. So for every cell that I have visited, I want to maintain the remaining k value. Please write RK in the chat. I want to maintain the remaining number of k that is left with me. Okay, this is one thing that I would want to do. Correct? Is this point clear, guys? Is this point clear to everyone? Quickly let me know. That is what I would like to do. And this is what I would want to do, and also the number of steps that I have taken. So the number of steps that I have taken till that particular cell, like if I move down, so at this cell I have taken one step, so the number of steps is what I would like to store. So I am saying that basically in my queue I would like to store my x-axis, the current x-axis, the current y-axis. I would also like to store the number of steps. Okay, and another thing that I would like to store is the remaining number of k, like the number of walls that I can cross from that point. Correct? Is this point clear to everyone? Quickly give me a plus one in the chat, guys, if you are clear till this point. I have tried without using a visited array. Okay, you can try that out also. That also works fine. If that works fine, then there's no issue. Okay, so now what you will be doing is we can do what okay, so furthermore what we'll do is now we'll start with the bfs. So can I say that in my queue, like if in my queue, you can see that in the queue, like every I need to store the data like this. Okay, I need to store the data in form of an array, right? So what I will do is I'll declare a queue that will be in form of vector. No, this is not backtracking, because if you will consider backtracking, you want the shortest path. That is why we are using bfs. Okay, so I'll declare the queue like this, a queue of vectors. Is this point clear? Please write clear in the chat, guys, for those who are clear with this point. So I'll declare a queue and I'll name it as vector int, and let's name it as queue. And initially what I'll do is I'll initially in the queue, I'll push the index 0, x-axis as 0, y-axis as 0, the number of steps that I've taken till now as 0. And another thing that I would like to push is the number of walls that I can cross. So initially from the 0, 0 cell, I can cross k walls at most. Is this point clear to everyone? Please quickly let me know in the chat, guys, and then I'll proceed further as well. Till this point, everyone is clear? Till this point, everyone is clear? Then I'll proceed further. Okay. Okay. Now what I will do is I'll run a BFS call. Okay. So I need to do another thing. I can do what? I can mark the current cell as visited also. So that I can do inside the cell also. So I'll say that while let's say not of queue dot empty. So while the queue is not empty, right? Till that point of time, I'll keep on traversing. And what I will do is let's say I'll say that auto let's say array is to what? Q dot front. So I'll take out the front of the front node that will contain the array. Okay, that is what I'll do. And I'll say that okay, the x-axis is going to be nothing but ARR 0. That is the first index. The y-axis is going to be nothing but what? ARR 1. Okay, and I'll say that okay, let's say the steps that I've taken till now is going to be what? ARR 2. And I'll say that int remaining k is going to be nothing but what? ARR at the index 3. Correct. This is what is going to happen. Right, guys, this is what is going to happen. Till this point, everyone is clear? Till this point, everyone is clear? Okay. Once I have the x, y axis, so what will I do? I'll check that if x is lesser than 0, okay, or if it happens that y is lesser than 0. If the current x axis, y axis that I'm at, if they are invalid, so if the x is lesser than 0, or you can say the y is lesser than 0, okay, or it happens that let's say x is greater equal to n, or it happens that y is greater equal to n. So if they are exceeding the limit, if they are not in the range, if they are not cells that are representing inside the grid, so I'll continue from them. I'll move forward. So I'll say that continue. Okay, this is what I'll do. Now suppose that if x is equal to n minus 1 and y is equal to m minus 1. So if I reach the last cell, okay, understand this point. If I reach the last cell, then I'll do what? I'll return the number of steps that I've taken. Correct, guys? Is this point also clear? Till this point, everyone is clear? Okay, just quickly let me know. Let me see if my voice is clear or not. Till this point, everyone is clear? Everyone is clear till this point? I hope that everyone is clear, right? So if I reach the last cell, then I'll do what? I'll return the number of steps that I've taken till now. Otherwise, what will I do? I'll check. What will I check? I'll check that suppose if the current matrix, okay, if the current mat of x-axis, y-axis, okay, suppose that it is equal to 1. So it is a barrier, now. It is a barrier. So I need to check what? I need to check that if the remaining number of k, okay, suppose it's lesser equal to 0. Okay, if it's lesser equal to 0, so if it is not there, if the remaining number of like if I do not have any capacity to to move from the walls, right? So I'll simply continue from there, no? So I'll say that continue, correct? Is this point clear? That if I do not have any capacity left to move through the walls, then I'll simply mark it as continue. Otherwise, what will I do? Otherwise, what will I do? I'll say that I'll mark remaining k minus minus. So I'll decrease the number of k high dual. So I'll decrease the number of k. Okay, otherwise. Is this point also clear to everyone? Okay, I hope that till this point everyone is pretty much clear with it. Okay, is everyone clear till this point? Please give me a clear like yes in the chat if everyone is clear till this point. Okay, now there can be several things that can be happening. Okay, if you will see, so I am saying that visited of like if I am saying that visited of let's say xy. Okay, if it is -1, so it means it is not visited. Otherwise, it will be visited. Correct. That is going to be the thing. Okay, so in the visited arena, in the visited of xy, you can say this thing that in the visited array of xy, what will I store? Okay, like will I just do this thing? Will I, if it is visited, will I just mark it as one? No, I should not do this. Why? Because there's one more thing that I want to do. Okay guys, I can simply say one thing, like if you like see, don't you think like we all do what, like we all do savings in our life? Please write savings in the chat or s in the chat. We all prefer to do savings in our life, right? Savings. Please write S in the chat. We all do what? We all do savings in our life. Okay. So similarly, in this question also, we will do savings. Please write S in the chat. Okay. Then I'll explain this concept as well. We will be doing savings. What kind of savings we'll be doing? Okay. So if you will see one thing, right, guys, understand this thing. Understand this thing. That if I have zero, okay, then I have one, then I have zero. Okay. If I have zero, zero, zero. Suppose there are other cells also, right? Suppose that the matrix is quite large. Okay, we don't care about it. So let's say that if let's say k value is equal to 4 here. Okay, so if you will pass through this cell, okay, if you will pass through this cell, then the k value will be 3 here, and then you will go down. Then what will happen? For this cell, your k value will come out to be 2. When you are at this cell, when you are at this middle cell, that is this particular cell, then the k value will be what? You will say that okay, the k value for me now is 3. Correct. But you will try to do what? You will try to be prepared. Okay, you will try to be prepared for the worst. Okay, for the worst. So the first target is what? The first target is to at least reach the ending cell, and we will try to do that optimally. So there's another path. Now you see here, if you will see here, let's say if you go down, so here the k value is 4 for this cell. If you go down also, so it does not get hit, so k value is 4. Then you go right, so for this cell, right, you can see that the k value is 4. The k value is 4, correct? So the number of walls that you can pass from this cell is 4. And if you went through another path, so the number of walls that you could pass through is 3. So which one would you like to go through? You would like to go through the path that has more number of k value, which has higher remaining k value, na? Which has higher remaining k value, correct? Which has higher remaining k value. Please write rk in the chat if you are clear. Then you can write rk clear in the chat. Okay, it is not a GitHub command, but it's basically a normal thing that you will try to conserve as many passes as you can, right? You will try to save as many passes, as many remaining k that you can, so that you can pass through the walls later on, because ultimately your idea is to reach the cells as much as possible, correct? So suppose I am saying that, suppose if I will reach this particular cell now, suppose that if I will reach a particular cell, suppose that when I reach this cell now, when I reach this cell, suppose, so if I reach this cell, so in this cell I'll mark it's visited with the remaining k. Okay, okay. So what I'll do is I'll mark this particular thing as visited as remaining k. Okay, so visited will be updated. Visited array will be updated with the remaining number of k's. Okay, so here the remaining k will be what? If the k value is 4, then k is equal to 3. Okay, then what will happen? Then I'll reach this particular cell, guys. Right? I'll reach this particular cell, middle cell. So k value will be 3. So I will update this particular thing as 3. Is this point clear? Please write 3 in the chat. Is this point clear? That if I first of all from the starting, if I go to the right, then I go then k is equal to 3 there. Then if I go down, right, so here you can see that for the middle cell, this particular cell, k value will be 3. So I'll mark the visited as 3. Is this point clear? Please write clear in the chat, guys, and then I'll proceed further as well. Till this point, everyone is clear. If you will stay till the end, you will understand everything. Please write 3 in the chat. So what I will do is in the visited array, I'll mark this particular thing. How does this prevent the cyclic path? So this will obviously prevent the cyclic path because uh, can you give an example? Could you give an example? So I'm giving this example only now. Like if you visited will always be saving you, so you don't need to worry on that. I'll explain this as I go forward. But basically, what you need to do, like if this thing happens, right? If you have k is equal to 3, right? If you have k is equal to 3, and suppose that after some time you follow another path and you go through this cell, like suppose that what you do is, if you see another path that you'll be obviously traversing through BFS, so if you come down and you go right, so now here k value is 4. Okay, so you will check what, like here the remaining k value is 4. So you need to check what, you need to check that if it happens that the visited of the current x cell and the y cell, if it is not equal to -1, okay, because obviously it is equal to 3 here. Okay, if it is not equal to -1 and the remaining number of k currently, right, and this thing is there, like if you will see here, if the visited of xy, right, current xy, if it is not equal to -1, right, so that means if it has already been visited, that is fine. But you also need to check now, at most 4 times you will be coming there, right? So if it is not equal to -1 and it happens that visited of, let's say, xy, okay, let's say the visited of xy, that is the basically it will tell the remaining k state, the already remaining k state. Okay, if it has more number of remaining k then compared to the current remaining k, if it is greater equal to the current remaining k, then I will simply continue from here now, right? If I am, like, let's say that if I am coming through this path, like if I am coming through this path, let's suppose that if it happens that if I was coming through this part, let's say this is also 1. So if I'm coming from here, coming down, so k is equal to 3 here, right? Suppose k was 4. If I pass through one boundary, one wall, so k will be 3 here. Suppose that if I'm coming from here also and I come here, so k is 3 here also. The remaining k will be 3 here also. So I'll not update it now. I'll not update it. But otherwise, suppose that if I initially, if this is the graph, if so if I come here, so the remaining k here is what, 3. If I go down, remaining k will be 3. So in the visited array, I'll mark it as 3. Okay, but if I cross through this path, then I'll see that okay, the remaining k is equal to 4, so it is greater. So then I'll update the remaining k, right? Is this point clear? So if it is positive, then it means that it is visited. But if I need to update it, then I'll update it as well. Is this point clear to everyone? Is this point clear to everyone, guys? Quickly let me know in the chat. Is this point clear? Like this particular point is clear. That is how I'm cleverly going to use my this thing, the DFS array, like sorry, the visited array. So what I'll do is I'll say that if the visited of the x cell and the y cell, if it's not equal to -1, so if it's visited and it happens that the visited of in this particular visited cell, if the xy is indicating the remaining number of k, so if it is greater or equal to the remaining k as of now, okay, then I'll simply continue from here, right? If I have more number of k coordinates left with me, then I'll continue. Otherwise, what I'll do is I'll mark the visited of xy, okay, with the remaining k, because I need to update it now. If I'm getting something better, if I'm getting more number of k's there, then I'll save it. This point is also clear to everyone. Okay, this is what I'll be doing now. After this particular point has been done, then what's the next thing that is required? So we will store the other cells, right? So they will be what, it will be like x minus 1 comma y comma, you can say what, the number of steps will increase by 1, so the number of steps till now plus 1, and I'll also pass the remaining number of k here. Okay, similarly, I'll say that q dot push. If I move down to x plus 1, comma y, comma, the number of steps will increase by 1. So steps plus 1, and I'll pass the remaining k value here. Okay, so this is what I'm going to pass here as well. And once this has been done, so I need to go in the other two directions. So I'll say that q dot push what? I'll push x comma y plus 1. That is if I'm moving to the right. I'll pass the number of steps plus 1, and I'll pass the remaining k as well. Okay, so this is what I'll be doing here. And then I'll do what? I'll say that q dot push x comma y minus 1 comma steps plus 1 comma remaining number of k. Okay, so this is how it's going to be like. And if I am able to reach the steps, so I'll simply return the steps. Otherwise, if that is not possible, so I'll return nothing but -1 from it. Okay, is this point clear to everyone? Or till this point, everyone is clear? Quickly let me know in the chat, guys. I'm still looking at the chart. Is everyone clear till this point? Let's try and compile this code also to see if it can work or not on the sample test case. So I hope it will. Okay, it says that vector of vector. Okay, so there are some compilation errors that I need to fix. Okay, let's see how many compilation errors we get. It's compiling very slow, to be honest. Let me check my internet speed also. Okay, please optimize your code. It says time limit exceeded. Why is this happening? If I have n comma m, so is there something wrong that I'm doing with my code itself? If it is not equal to -1 and it's greater equal to, so is there something wrong that I'm doing with my code? Let's check that part again. So what I've done is I have taken first of all a visited array. Okay, so am I popping out? No, I was not popping out now. So I need to do q.pop also. This is the part that I was missing. Right. So I needed to pop out as well. Otherwise, it will obviously give me time limit exceeded. Yeah, I missed the pop out part. Correct, Rishit. Now let's try and submit this code and see if it works or not. Okay. So I hope it will work. Yeah. So you can clearly see that this code gets accepted for all the solutions, all the possible test cases that have been given to us. Right. Is this point clear, guys? Is everyone clear with this question now? Till this point, everyone is clear. If you're clear, you can write like clear in the chat, guys. Okay, so this is what I've done in this question. So basically, this is one of the examples where you can take the visited array. Okay, this is one of the examples where you can take this visited array for comparison. Could you explain the visited array comparison again? So basically, Rishit, I am saying that in the visited array, na, if the visited of xy is -1, then it will indicate that it has not been visited. Okay, if it will indicate that it is not visited. But suppose that if I am 0, okay, 1, then 0, like let's say if I consider this kind of a case. So if I like, let's say k is equal to 4 in this case, right? Initially when I'm starting, then k is equal to 3 here. Then if I move down, then k is equal to 3 for this cell also. Now, like I can, from this cell I can only pass through 3 walls. So I am saying that for this cell I'll mark the visited. Okay, I'll mark the visited as 3 here. Okay, so basically I'll mark the visited will not only indicate that it has been, I am trying to hit this, right? You will try to visit it because see here you have visited it, right? If you pass through this path, then you have visited this particular cell, right? That is true. But do you want to visit a particular cell with lesser number of walls? Do you want to go forward from here with lesser number of walls, or do you want to look for better opportunities? You want to look for better opportunities as well. So how many times at most you will be visiting? If there is a particular cell, then you might hit it from here or here. So right, most of the times I don't think that there's like, or maybe you can hit it from here or here, right? So only 4 directions maximum are possible now. So only 4 times you will be checking this thing at most, right? And you'll, out of those, you'll be considering the maximum out of them. So let's say if you'll consider this particular path, right? So if you have k is equal to 3 here, we will always ignore one cell, right? Will always ignore one cell. Why will you ignore one cell? You will not ignore it. You will try to take the optimal ones. Okay, so if k is equal to 4 here, if you go down, k is equal to 4 here, then you'll come here. So k is equal to 4 here. Now this is better. Now here the remaining k, basically when I say k, so here the remaining number of k is what, more than it, right? So if at this cell you're, by following some other path, if you're having more number of k's remaining, if you have more capacity to cross through the walls, then you'll try to take that leverage. So that is why if it is already visited, if it is not -1, and you are currently having more number of more capacity to pass the walls compared to the path that you are currently coming from, then you'll continue. Otherwise you will update now, because if you can if you have more remaining k, then you'll say that okay, the visited array for this particular cell should be updated with 4, because I have one more, I can pass through one more. If I follow another path, then I can pass through one more wall, so that will be 4 walls total, right? So we are not ignoring the walls. As much as possible we'll try to ignore them, but not always. Is this point clear? and that is how we are doing it. So obviously now when you will see the time complexity for this approach, in the worst case it's going to be kind of order of n cross m only, you can say, because I am not iterating more than that. Every cell almost is visited this much only, like maybe you can say 4 in also, but overall it will be overall the complexity will be n cross m only, and the space complexity if you'll consider, so I'm taking a visited array, so it will be n cross m also. Is this point clear to everyone, guys? Is it clear? Quickly let me know in the chat. I hope that this particular problem has is clear to all of you. This question was asked in Google, and you can understand why and how it was asked. Okay, so again, I'll walk you through the code. So what I do is, okay, thanks a lot, Naikaj. So what I'll do is, first of all, I'll take a vector of vector, that is a visited array, 2D array. Initially, I'll mark it as -1 n cross m size vector. I'll push the inside the queue, I'll push the vector. Then what I'll do is I'll push the zero cell, zero x-axis, zero y-axis, the number of steps initially are zero, and the value of k, that is the walls that I can pass through. Okay, is easy problem? What do you think? I also think that it's a easy problem. It's a medium problem, to be honest, not that easy also, but you can hit the like button if you have understood till the end. Okay, and you can give me a +1 as well if you learn something new from this. Then I'll have an array in which I can use the auto keyword to store this array from the queue.front. I can pop it out. Then I can get the x-axis by doing array of 0. By doing array of 1, I can get the y-axis. I can get the number of steps till this particular cell as array of 2. I can get the remaining k as array of 3. And if this particular cell that I'm at, if it is invalid, if it is outside grid, then I'll simply continue from it. Okay, otherwise if it happens that the current cell that I visited, if it is the last cell, right, so that means I have reached the destination, that is from topmost leftmost I have reached to the bottommost rightmost. So I'll do what, I'll simply return the number of steps till now. Otherwise, if this particular cell is 1, okay, if it is 1, then in that case I'll check that do I have the capacity to pass through a wall, do I have any remaining k. If the remaining k is lesser or equal to 0, so if it is not there, or you can say 0 also, so if I do not have any capacity to pass through any wall, then I'll simply continue and I'll move to the next iteration. Otherwise, I'll reduce one of my remaining case, okay, and I'll now check that if the current cell is not visited, like if the current cell is already visited and earlier I was having more like more remaining k compared to the current remaining k, then I'll continue from here, because if I was saving more earlier, then I will not try to disrupt it. Okay, I have used priority queue, but it will take more time complexity. Na priority queue will take kind of logarithmic of n factor more will be there, so you don't want such kind of thing to happen with you. Otherwise, what you will do is you'll say that if currently you're getting more walls, if you're currently getting more if you're currently saving more number of walls for yourself for the future, then you'll update your visited of xy as remaining k, and then you will push all the 4 directions, that is x minus 1 y, x plus 1 y, x y plus 1, x y minus 1, that is in the upward, downward, rightward, and leftward direction, and you'll increase the number of steps by 1, and you'll simply pass your remaining k as well. In the end, if the queue ends, if the BFS ends, and this will mean that you never return the number of steps, so that will mean that if you come out of this loop, so you'll return -1, because that particular path will not be possible. Okay, guys, is this point clear to everyone? I hope that overall the problem is pretty much clear to everyone. Is it clear? So I'll give you my code as well. Okay, so just a second. I'll provide you with my code as well so that you can go through it. So I'll generate a link for it as well. But I hope that this particular question is clear to everyone. You can write clear in the chat once again if you're clear till this point, till the very end if you have stayed and you're clear with this question. So you can hit the +1 as in the chat as well. Let me generate the uh, link for this question as well, for the solution, sorry. So I am going to share the solution with all of you. So this was the solution, guys. Rishit is clear with it. Okay, you have used a priority queue, that is fine, but it will add extra time complexity, so that is why I have not used it. Visited part was interesting. Yeah, it was another good concept. That is why this particular problem was asked in Google, guys. Okay, so I think still a lot of people are watching us. So please hit the like button, guys, if you haven't. For one last time, I'm asking that you can hit the like button if you understood this particular problem inside out. And then I can end the session as well. So is everyone clear with the question overall? Simply you can understand that this particular question, if you look at this question, so it was asked in companies like Google, and you can also see the relevant courses related to this and the relevant topics of this problem. So you can make sure to solve the problem of the day every day, because if you'll see, the POD for today is the distance of nearest cell having 1. So try to solve this one as well. And I think Siddharth will be taking this problem tomorrow. So make sure to come up tomorrow by solving this problem on your own. Again, you can give me a +1 in the chat for one last time, and hit the like button if you haven't, if you have understood this solution. And thanks a lot for joining this particular session, guys. And good night. Take care. Happy coding, guys. Bye. And keep coding.